Good morning, my dear students. So, after studying the nature of the roots, we are going to head to the new topic, that is relations between roots and coefficients. Okay, so let us understand the meaning, the relationship between the roots and the coefficients. You know what is the meaning of roots, and you know the meaning of the coefficient. If I write a quadratic equation ax plus ax square plus bx plus c equal to 0, then a, b, c are the coefficients, and let us consider alpha and beta are the two roots of this quadratic equation. Now we are going to study that what do we mean by sum of the roots and product of the roots. What do you mean by sum of the roots? If we are considering alpha and beta, that means alpha plus beta, and product of the roots will be alpha into beta. So you know there is some relationship between roots and coefficients. If you add both the roots of the quadratic equation, no, you will get minus b upon a, this minus of b upon a. And if you multiply both the roots, you will get c upon a. Now what is the proof? How can we prove this alpha plus beta is equal to minus b upon a and alpha into beta equal to c upon a? Let me just explain you with a very short example. Like if I'm taking a quadratic equation x square plus 4x plus 4 equal to 0. This is a quadratic equation I'm taking. So as this is the x plus 2 the whole square identity, and from here I'll get the two values of x as minus 2 and minus 2. So let us consider this as alpha and this as beta. Alpha plus beta, what will be your alpha plus beta? Minus 2 plus of minus 2 minus of 4. And let us calculate on the other side minus b upon a from this quadratic equation. So minus of what is b? 4. And what is your a? Minus of 4. Hence it is proved that alpha plus beta equal to minus b upon a. This relationship is proved. Similarly, we can go ahead and prove for alpha into beta. Alpha into alpha is minus 2 into minus 2. We'll get 4. And similarly on the RHS you have c upon a. What is c? 4. And what is a? 1. So we got 4 as a answer. So that this is how we have made the relationship. You know, the mathematical proof is really very simple, as you have to do this mathematical proof. What are the values of x minus b plus under root b square minus 4ac upon 2a, and the another value is minus b minus under root b square minus 4ac upon 2a. If you add both of them, that means there will be plus sign between them. This is proof. If you add both of them, you will see that the denominator is same. This will be cancelled with this one. You will get minus b upon 2a. So minus b upon a. So that is how you can go ahead and do for this one also. Okay, understood? I guess you have understood. Now the next thing which they are trying to explain is some of the formula, the symmetric functions of the root. They have given the name. So I think you can understand that alpha minus beta the whole square can be represented as alpha plus beta the whole square minus 4 alpha beta. If you have a quadratic equation, then you can find the difference of the root. If you have one quadratic equation, from there you can find alpha and beta or the two roots of the equation. And if you are asked that find the difference of the root, so this formula you can apply. You know how this formula came? If you expand this alpha square plus beta square plus 2 alpha beta and minus of 4 alpha beta, so automatically you will get minus of 2 alpha beta, and they both will be equal because alpha minus beta the whole square is nothing but alpha square plus beta square minus 2 alpha beta. So that is how they have represented. And if you see the second one, alpha square plus beta square, it can be written as alpha plus beta the whole square minus 2 alpha beta. Alpha to the power 4 plus beta to the power 4, they have written alpha plus beta the whole square minus 2 alpha beta the whole square minus 2 times of alpha beta the whole square. Okay, if you expand, no, you will get this only. Similarly, alpha square minus beta square, they have written alpha plus beta and alpha minus beta. So that is how we will be molding according to the situation, according to the question, and we'll solve the things. Okay, now just one more thing and then we'll start the questions. All right, so this is the last topic which we are going to see. It says to find condition when roots are connected by given relations. So if say for example, if you are given the two quadratic equation, let there be two quadratic equation, this one and this one, a1x square plus b1x plus c1 equal to 0 and a2x square plus b2x plus c2 equal to 0. So the two condition arises. If one of the root is same, that means of this and this, if one root is common, then what condition, by which condition you will check that whether these two quadratic equation have the one common root. And if both the roots are same, that means the roots of this equation and the roots of this equation to be both same, what will be the particular condition of it. Okay, so I'm giving you a very short trick to remember that if one root is same or not. So let me just write AB, AB, B, C, B, C, this is equal to CA, CA. Okay, first of all, write AB, AB, BC, BC and CA, CA, 1, 2, 2, 1, 1, 2, 2, 1, 1, 2, 2, 1. And one more thing, you have to put square also here. So this is the condition of finding that whether one root of this pair of quadratic equation is common or same or not. Okay, I have written in a very proper way so that you can understand. This is the mnemonic of remembering the formula. AB, AB, BC, BC, CA, CA. Put square, then 1, 2, 2, 1, 1, 2, 2, 1, 1, 2, 2, 1. And what will be the condition? This is very simple. A1 upon A2 equal to B1 upon B2 equal to C1 upon C2. Now you would be thinking like, how? If the roots of this equation is equal to the roots of this equation, that means they both quadratic equation should be same. Okay, yes, that is correct, but like say for example, I'm writing 2x square plus 8x plus 8 equal to 0 and x square plus 4x plus 4 equal to 0. You will get the same root of these two equations and they both are different one, as the roots 2 upon 1, 2 upon 1, 2 upon 1. And if you take 2 common from this quadratic equation, you will get the same quadratic equation as that of this one. So that is what, if two quadratic equation have the same roots, then this condition exists. You know, you can understand this thing with one of the topic which we have seen in the 10th class, that if two linear equation lie on each other, that means this is which case, when two lines coincides. We have three conditions: intersecting condition, parallel condition and coincide condition. So in the coincide, all the that means a1 upon a2 is equal to b1 upon b2 equal to c1 upon c2. The same thing we are going to use in the quadratic also. Okay, now understanding all the basic part, let us come to the questions now. Okay, so here is the question. If alpha beta are the roots of the equation 3x square minus 6x plus 4 equal to 0, then evaluate alpha square upon beta plus beta square upon alpha plus alpha upon beta plus beta upon alpha plus 2 times of 1 upon alpha plus 1 upon beta plus 3 times of alpha into beta. So first of all, let us find what is alpha plus beta and what will be alpha into beta. So as alpha plus beta, by the relation we know b up minus of b upon a. So our a is 3, b is minus of 6 and c is 4. Okay, so minus of 6 upon 3 will get 2, and alpha into beta will be c upon a 4 upon 3. Okay, now just let us simplify this expression which we have to evaluate. See, we can get in this denominator we can get alpha into beta, here also alpha into beta, here also alpha. So take the LCM, so it will be alpha cube plus beta cube upon alpha beta, plus here also alpha square plus beta square upon alpha beta, plus here wait, yeah, correct, here also we can get will get alpha plus beta upon alpha beta. Okay, and plus of 3 alpha beta, alpha beta, alpha beta, alpha beta. If we take whole LCM, so we'll get this will become alpha beta the whole square and whole divided by alpha into beta. Okay, now we know the value of alpha plus beta, we know the value of alpha beta here and this one also, but we don't know alpha square plus beta square. Let us use the identities and let us write. We can use a cube plus b cube identity. What is that? A cube plus b cube, a plus b bracket a square plus b square minus ab, and in place of this, what can we write in place of this? We can write alpha plus beta the whole square minus 2 alpha beta. In the very starting I have stated how this can be this one, plus 2 times of alpha plus beta and plus 3 times of alpha beta the whole square, whole upon alpha beta. Now again, in place of this we can again put whatever we put here. So alpha plus beta, wait, so such will be the situation. In place of this alpha square plus beta square, we again put alpha plus beta the whole square minus 2 times of alpha beta, and this alpha into beta, and plus the same all the things. Now we have expressed this in terms of only alpha plus beta and alpha into beta. You have alpha plus beta value and alpha into beta value. Just put all the way and get the answer. Okay, I think you can do this one. There's no problem in it. Alright, let me give you a hint in this question. You are given that if px square minus 2p plus 3 times of x minus p plus 1 equal to 0, and you are given with one root is equal to 3, find p and the other root. You have to find the value of p also and what will be the other root of it. Okay, so how are we going to do this question? So like for this question you have two ways. The one very common way is you have one value of x, that is 3, you put in this equation, because we know both the root of the equation satisfies the equation. Alright, so finally you will get the value of p. Put this value in the that means quadratic equation and just solve it. You will get the obviously you will get one root as 3 and another one also you will get. This is the first method. Now what will be the alternative method for this one? Use the relations. We know alpha plus beta is minus b upon a and alpha into beta is equal to c upon a. Consider alpha is equal to 3 because one root is given. So 3 plus beta equal to minus. B is what? Minus of 2p plus 3. So it will be 2p plus 3 upon a, that is p. Okay, and alpha, that is 3 beta equal to c upon a. So minus ka p plus 1 upon p. Now I think you will understand how we can do this question. In place of, you take 3 in the denominator here. Okay, and this 3 plus in place of this beta we can put this, so minus of p plus 1 upon 3p equal to 2p plus 3 upon p. Now just solve it. From here you will get the value of p. Similarly, if you get the value of p, put in this one, or in this one you will get the value of beta. So that is how you have to do. Or I guess you can do this question. Let me see, up to 7th question you can easily do. Okay, so 6.4 exercise up to question number 7, please try to do. Okay, and in the next video I'll come up with the more questions of 6.4 exercise. Alright, so don't worry, do the examples also. Okay, and write the basic things and complete it till this whatever I've taught and whatever I asked to do. Okay, till that, thank you so much, have a nice day, bye bye.